All right, so section 3.3. So we're going to get into some of the rules of differentiation um, because a lot of times finding derivatives is not as simple as finding limits, for example. And what I mean by that is when we talked about limits, if you had two functions that were added together, you could just take the limits of them separately and add the limits together. Same thing with subtraction, same thing with multiplication, same thing with division. With derivatives, though, you can do that with addition and subtraction, but you cannot have the product of two functions and take the derivative separately and then just multiply the derivatives together. It's not how it works. So we have this rule called the product rule. And it looks a little bit complicated at first, but it's really not too complicated. And in fact, you could probably write it a little bit easier. So if you wanted to say, if we use the prime notation, so the derivative of f times g, really what we're doing is we're going to leave the first function, whichever, and it doesn't matter which one, because it just, the order doesn't matter here. But let's say we leave f the same, and then we're going to multiply f by the derivative of g. So we put parentheses around that. If you like, well, maybe not. That might be confusing. So we're going to take f times the derivative of g, and then we're going to do the opposite. We're going to take the derivative of f and then multiply it by g. So we have f times g prime plus f prime times g. And so that's all this is saying. It looks a little bit more complicated with the d over dx, I think. But this is what we're doing, and it's not super complicated. I think you'll probably get used to it pretty quickly. Maybe you might need to write the formula. I typically recommend that when we're using formulas, you can write the formula before you use it. Maybe not in this case. I think if you do these several times, then it gets pretty rote as far as process here. So maybe so we have x times e to the x. So on this one, we can't use f and g because we have an f here. So let's use u, and let's say u, and let's say v. And so f prime would be u times v prime plus u prime times v. All right, so we're going to write u. So the function, in this case, u is x. V prime is the derivative of e to the x. The derivative of e to the x, I think we did this in 3.1, is just e to the x. Then we're going to take the derivative of u. The derivative of x is 1, and then leave v the same. So u is x, v prime is e to the x, u prime is 1, v is e to the x. And so this derivative, not really much to simplify. A lot of times you'll have things to simplify, but in this case, not really much. So f prime in this case is x e to the x plus e to the x. So that is our first derivative. We can find the second derivative the same way. So we're going to use the product rule on this first term. Second term is the derivative. We just take that one the normal way. So f double prime. And so we're going to do the same process. So the derivative of x e to the x, we actually just found. So we'll just write that part again. So this part is x e to the x prime. All right. And then now we're going to take the derivative of e to the x, and that is just e to the x. So this term is e to the x prime. So again, with addition, if you're adding two functions, here we are adding x e to the x plus e to the x. We're adding two functions. Just take the derivatives separately. For multiplying, you got to use this product rule. And now we can simplify this one. So we have x e to the x, and then we have e to the x plus e to the x, so that would be plus a 2 e to the x. And that would be fine. I think, well, yeah, that we'll leave it like that. We could factor out an e to the x, but that we don't really need to do that. But that's the idea. So identify the two functions that are being multiplied together, take the derivative of one, hold the other constant, and then take the derivative of the other and hold the first one constant. So we'll do one or two more here. So next we have 2t to the third times 3 plus 5t. So now you don't really have to do this every time. You probably will get used to, well, you should get to the point where you don't need to write the u function and write the v function, but we'll do this at least for the video here. So the u function is 2t cubed, the v function is 3 plus 5t. So then if we want to find g prime, that would be u v prime plus v times u prime. So the u is 2t cubed, v prime would just be 5, plus v is 3 plus 5t. And then u prime, using the power rule, would be 6t squared. And so now this one we do have to simplify a little bit. So 2t cubed times 5 would be 10t cubed, plus, now distribute the 6t squared here, so we have 18t squared, and then plus 30t cubed, combine our like terms, and we get 40t cubed plus 18t squared. All right. All right, let's look at the next one. Now, the next one's a little bit different because we have an abstract g function here. So we don't have an actual g function to work with, but we still kind of do this the same way. And so we're going to let the u equal square root x. We're going to let v equal g of x. And so in this case, and you can do this too if you like, go ahead and write the derivative of u. So that would be 1 over 2 square root x. And actually, just the way we kind of did this, and the way I would suggest to do this, is write the square root or any radical that you have. Write it as an exponent, so x to the 1/2. And then to take the derivative, we just use the power rule. So we have 1/2 x to the negative 1/2. Move the negative exponent to the denominator, and then convert it back to a square root, and that's where you get that. So don't want to run over that too fast. You kind of, once you do derivatives for a while, you kind of get used to doing, I mean, this one you see a lot, so you don't really have to go through this process after a little while. Then v prime is just the derivative of g. We don't know what g is, so we're just going to write g prime of x. So then we have f prime of x would be u v prime plus u prime v. So we have square root x. V prime is g prime of x. U prime is 1 over 2 square root x. And then v is just g of x. Now we want to find f prime of 4. So now we're just going to plug 4 in for all of our x's and simplify. So we have square root 4, g prime of 4, plus 1 over 2 square root 4, and then g of 4. All right, square root of 4 obviously is 2. G prime of 4 is 3, so this is 2 times 3, plus 1 over, that would be 2 times 2, so that'd be 1/4. And then times g of 4, which is 2. And then just simplify this. So we have 6 plus 2/4, which would be 1/2. And so we get 6.5 or 13/2. Okay, so when you have an abstract function, and there's no point in doing one like this unless you have a couple of values that you're interested in. So yeah, so just kind of plug that in for the v, and then plug in the numbers after you get the derivative. All right, now I think that's it. We get to the quotient rule. Yeah, so we'll stop this one and finish up on the next video.